Welcome back to Algebra with Miss Swartz. Per request, I'm just going to go over some of the things we went over last week in class. So I'm not going to spend tons of time like it's new material because most of you have already seen the information. But I want to discuss parallel and perpendicular lines as well as scatter plots. So let's get started. We talked about parallel lines and their slopes. So two lines in the same plane that never intersect. Those are obviously parallel lines. You've probably worked with parallel lines a lot. But something new we're going to be using is the fact that we can know that lines are parallel if they have the same slope. Okay? So we worked a lot with slope. We worked a lot with finding slope. So we're going to use that idea to help us know if we have parallel lines or not. So we looked at this example and we said, all right, what are the slope of these lines? And we can count those out. For line A, which is in blue, we counted 1 down, 1, 2, 3, 4, 5 over. So we know it's going to be negative 1/5. For the red, or B, we counted 1 down, 1, 2, 3, 4 over, so negative 1/4. Those are not parallel because they don't have the same slope. Eventually, these would intersect if they continued on forever. And then C, 1 down, 1, 2, 3, 4, 5 over, so that would be negative 1/5. So A and C would be parallel. Okay, so then we also talked about, okay, what are some ways we can write in equations? Well, really, to write an equation, we need its slope, and we need a point. We talked about point-intercept form in 4.2. So it says write an equation of a line that passes through 5, negative 4. There's our point, and is parallel to the line y equals 2x plus 3. Well, we have our point. We just got to know our slope. Well, if our line is going to be parallel to this line, my slope is going to be 2. So what I did here was I used point-slope form. Y minus y1 equals m, or slope, times x minus x1, and I plugged it in. So y plus 4, because minus a negative 4 would be plus 4, equals 2, that's my slope, minus times x minus 5. Now to get my y alone so that I'm in slope-intercept form, I'm going to distribute my 2. So I have 2x minus 10, and then I'm going to get y alone by subtracting 4. So we get 2x minus 14. We skipped over this example, but we would easily be able to find if the lines were parallel just by using y2 minus y1 over x2 minus x1. So I'll actually do it here so that you guys can see. So we would have had negative 1 minus 3 over negative 6 minus negative 5. So we get negative 4 over negative 1, or positive 4 for line A. For line B, we would have gotten negative 7 plus 2, or minus a negative 2, over 2 minus 3. So we get negative 4 over negative 1, which is also, sorry, this is negative 5. This would be positive 5 as our slope. So these are not parallel because they don't have the same slope. Below we did another example of writing an equation that passes through an ordered pair and is parallel to this line. So our slope is 1/4. We plug it into our points, we distribute, and we get y alone. So then we also talked about perpendicular lines. Slope is the same when it's parallel, but when it's perpendicular, it is the negative reciprocal, or negative meaning the opposite reciprocal. A little more difficult, but not much. And we talked about how negative 2, the negative reciprocal would be positive 1/2. Negative 1/4, the positive reciprocal, or the opposite reciprocal, would be positive 4. So for one of the classes, we went through all of these examples. I'm going to skip over this in the video. But you could get all of them to y equals mx plus b, which I think some of you are struggling a bit with. That way you can see what the slope is. So I will talk about that just with line B and line C. I'm going to subtract x because I'm working to get y alone. Then I'll divide by 4. So y is by itself. So I have to understand, if I break this apart, it's going to be negative 1/4 x. This is going to be positive 3/4. Same thing over here. I can add 2x, get negative 8y equals 2x plus 16, and then divide by negative 8. Separate those parts out. 2/8 is the same as negative 1/4 x, and then minus 2/16 divided by negative 8. So then you can look at your slopes and see if they're parallel or perpendicular. So the last example we did was another point, but this time we wanted it to be perpendicular to 1/2. So we knew the slope had to be negative 2, and then we plugged these points in. If we wanted to get y alone, we would say negative 2x minus 6, and then add 1 to both sides. So y equals negative 2x minus 5. Again, for this, we probably didn't get to this in class, but you would just need to change all of these to slope-intercept form to be able to determine if they're parallel or perpendicular. If we were to go ahead and do number 4 here, if it was perpendicular to negative 1/3, our slope would be, negative 3, our slope would be 1/3, positive 1/3. That's the opposite reciprocal. And we have our point at 3, 5. So we're going to plug it into y minus y1, or 5, and then equals our slope times x minus, or plus in this case, a negative 3, so 3. So then we would distribute 1/3 x plus 1, 1/3 times 3 is 1, and then add 5 to both sides. So y equals 1/3 x plus 6. Alright, then the next day we quickly talked about scatter plots. Scatter plots are a graph that shows relationships between two data sets. It can be graphed as ordered pairs, and they show trends in data, so we talked about positive and negative correlation. And a big thing with this is we talked about drawing lines of fit. So we looked at these, just how to read a scatter plot, how many calories are in the smoothie that contains 56 grams. We went over to 56, we went up to the calories. That would be 270. Okay, how many grams of sugar in a smoothie that contains 320 calories? Went up to the 320. That would be 70 grams. Okay, and what tends to happen to the number of calories as the number of grams of sugar increases? Okay, well, as sugar increases, calories also increase. So this is this positive correlation. We also looked at it kind of like I was just saying, positive, negative, or no correlation. So some examples of scatter plots here: age and vehicles owned. So we want to determine, does it have a positive, a negative, or no correlation? Well, if I look at the graph here, it's kind of all over the place. If I pick out some points here, the higher I get over here for person's age doesn't necessarily mean the higher I get over here for number of cars owned. So for this one has no correlation, meaning if we saw this information, we couldn't draw a line of best fit within here. But if I look at the next one, the temperature and coat sales at a store, as the temperature goes up, the number of coats sold goes down. And with this, I can draw a line that almost goes through a lot of points there. Okay, and I could pick out an ordered pair from that line. So like 65, 20, and even, here's one, 55, 30. Okay, and with this line of fit, as they call it, where it's showing the trend in the data, we could write a equation. Okay, so I could use this to figure out a slope. I could use y2 minus y1 over x2 minus x1, where I said 30 minus 20 over 55 minus 65. So I get 10 over negative 10, or negative 1 is my slope. So I'd have to use y minus y1 equals negative 1 times x minus x1. And I'd add 20. So y equals negative 1x plus 85. So it's telling me I would probably hit the y-axis at about 85 if I kept going, which looks almost correct. But with this, we can kind of judge our slope and our y-intercept. So for here, that means when it's 0 degrees, we're probably going to sell the most coats that we would. It could go negative. That's very unlike a scatter plot. But a lot of coats will be sold when it's 0 degrees. Also, it tells us our slope, as the temperature goes down by 1, we're probably going to sell 1 less coat, kind of thing. So we talked about how to make a scatter plot. You can use your ordered pairs in a scatter plot to graph points, and then decide whether it can be modeled by a line, like that line of best fit. This A over here could not be modeled by a line, but B could. And then we can draw a line that appears to fit the data closely. Okay, as many points about as above as below. And then we can write an equation like we just did. So that kind of sums up our day with scatter plots. Hopefully this was a good review. Hopefully this is a helpful reminder on a few different pieces. And we can grab these two concepts pretty well. Have a great day.